What's going on, guys? Mr. Jones once again. We're going to do task 3.7 pretty quickly. It has the potential to take longer, but we're going to kind of cheat a little bit, if you will, and do things a little bit different than what it actually asks you to do. So first and foremost, I'm going to read it to you, and then I'm going to summarize what it actually wants you to do. So Carlos and Clarita, Tia, Tahani, and their best friend Zach are all discussing their favorite methods for solving quadratic equations in the form ax squared plus bx plus c equals 0. So they're basically all discussing their favorite method for solving for the x-intercepts when they're given an equation in standard form. Each student thinks about the related quadratic functions as part of his or her strategy. And then below that, it lists all the different strategies, right? So Carlos likes to make a table. First and foremost, we're skipping Carlos. Okay, so we're skipping Carlos. You can cross him off, whatever you got to do. Okay, Zach likes to graph the quadratic function. I do expect you to create a graph. I'm going to show you some stuff in a second. Clarita likes to write it in factored form. Tia likes to write it in vertex form and solve it that way. And Tahani likes to use the quadratic formula to find the solutions. Okay, so I'm going to get you started. Actually, I'm just going to do one right here, this x squared plus 6x plus 8. And then you're going to do 3 problems. Also, before I forget, this equation right here, okay, the one that says 2x squared plus 3x plus 1, okay, 2x squared plus 3x plus 1. You're going to change that to, it looks like x squared plus 10x plus 9. So change that equation. So cross this one off, and then you're going to do all the work on that one for the second one instead. The other 2 are okay. All right, so go ahead and do that. All right, here we go. Let's just put it somewhere random. We'll never be able to find it. All right, so the one we're going to do is the one that I have up there on Desmos right now. Okay. And I have it graphed for you, so we already have the answers. But let's just do everyone's strategy. So the first person's strategy or one person's strategy, it looks like, who was the one that wanted you to graph? Zach, I like to graph. So you can graph yours, but I want you to actually graph it on paper. And there's specific things that you should have. You should have the vertex and the 2 x-intercepts and the y-intercept, and then even the point across from the y-intercept. So you should be able to give me 5 points, right? There it is, 5 points on the parabola. So I want you to actually graph it on paper, but good news, you can get it off Desmos to check it out. All right, so there's Zach's method. Clarita wants to write it in factored form. So if the equation is factorable, okay, then Clarita wants you to write it in factored form. Okay, so is this factorable? Well, does anything multiply by 8 and add to get 6? What about 4 and 2? So here is one method. This is Clarita's method, and then she solved it that way, okay? So now she said, cool, -4, 0, and -2, 0. All right, so there's Clarita's method. All right, now Tia's method, they put it in vertex form. We didn't really do much of that this year because of time. So you're going to look at this graph and see if you can figure out what vertex form is. Okay, you know the stretch is 1, you know where the vertex is. So if the stretch is 1 and you know where the vertex is, you should easily be able to say, okay, x plus 3 squared minus 1, right? There's the vertex and there's the stretch. So I just wrote the equation in vertex form. And then you solve it. So you just put in 0. You say x plus 3 squared minus 1. And now you just go ahead and solve this like we've been doing recently. So I'm going to show you. Add 1 to both sides. You get 1 equals x plus 3 squared. Then you're going to square root both sides, not forgetting the plus or minus because you need your 2 answers. Okay, this cancels. You get x plus 3, and you get plus or minus 1 because that's the answer. Square root of 1 is 1. Then you subtract 3 from both sides, and now you get -3 plus or minus 1, which turns into -3 plus 1, -3 minus 1, which equals -2 and -4. And those are the two answers from vertex form. All right. Last but not least on this one, you're going to do the quadratic formula. Okay, so I'm going to show you one last time how to do that. Remember, it's this method. There we go. All right, and remember the equation over there on the left. Okay, so in that equation, my A value is 1, my B value is 6, my C value is 8. And now we're going to plug in x equals -b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Okay. Then we solve the discriminant. Okay. So you can solve the discriminant here. 6 squared minus 4 times 1 times 8. 6 squared is 36 minus, okay, put your brackets here. 4 times 1 is 4. 4 times 8 is 32. 36 minus 32 is 4. This is my discriminant. We're going to plug it back in right here. Okay, so now you just rewrite the equation. X equals -6 plus or minus the square root of 4 divided by 2 times 1 is 2. Hopefully you know the square root of 4 is 2. So this turns into -6 plus or minus 2, all divided by 2. Now you can simplify this, and you can actually divide. So -6 divided by 2 is -3. 2 divided by 2 is 1. And now you just say -3 plus 1 and -3 minus 1. And I bet you figured out by now that we're going to keep getting the same answers because it's all the same equation. And there's the last person, right? So you're going to do those 4 methods: graphing, vertex form, factored form, and quadratic formula. And you're going to do that for this problem. So the first one here with all these boxes. And then the second one here, remember I gave you a different equation to turn that into. And the third one here, you're going to do that one. If the equation ends up not being factorable, you can't put it in factored form, so you're just going to say, hey, not factorable. Okay? All right, guys, if you have any questions, please let me know. I would love to help you. Have a great day.